Welcome to the Explainer. Every now and then, a piece of technology comes along that feels like it's been ripped straight out of a sci-fi movie. And that's exactly what we're talking about today. Ant Group, they're not just building robots. They're literally generating entire worlds for them to learn in. And this approach, well, it could change absolutely everything. Okay, so to really get this, let's start with just how huge this shift is. Think about it. For decades, if you wanted a virtual world, say for a video game or a simulation, it was just brutal, manual labor. Artists hunched over their computers, building it piece by piece, polygon by painstaking polygon. Weeks of work. Now, look at this new way. You give the AI a single photograph, and in a matter of seconds, it generates a playable, physically consistent world. I mean, come on. This isn't just an upgrade. We are talking about a totally different way of creating reality. So yeah, we're making this massive leap from rendering polygons that someone else built to generating reality, pixel by pixel. And the engine driving this incredible jump? It's something they're calling a neural physics engine. And this is the part that just blows my mind. The real key here is how it all works. Instead of a programmer sitting down and coding the laws of physics, writing, here's how gravity works, the AI, LingBot World, just watches. It watches thousands and thousands of video and just figures it out. It develops its own intuitive gut feeling for the physical world. It learns what happens when you drop something or when two things collide. And because of that, it can dream up an endless supply of realistic training worlds for robots, all on the fly. No human has to build a single thing. So you might be asking yourself, how does this insane technology fit into the bigger picture? I mean, this is coming from Ant Group, a company that, let's be honest, most of us associate with online payments, not futuristic robots. But it turns out they've been quietly building a whole full-stack solution to tackle some of the biggest problems in robotics. And they've packaged their whole strategy in this really brilliant way, as a 3-course meal. First up, the Appetizer. That's LingBot-Depth. This basically gives any robot with a simple camera the superpower of seeing in 3D. Then you get the main course, LingBot-VLA. Think of this as the universal brain, something that can understand commands and make decisions. And for dessert, and this is the craziest part, you get LingBot World. This is the digital sandbox, the dream world, where these robot brains can safely practice millions of different scenarios before they ever touch the real world. All right, let's get a little nerdy now and peel back the curtain. Let's look at the core tech that makes all of this possible. This is the secret sauce inside LingBot World that lets it generate these dreamlike yet physically consistent realities. Okay, so the engine is built on something called a diffusion transformer, or a DIT for short. The way it works is, it takes a video and smashes it into these tiny little puzzle pieces of both space and time. A transformer, which is the type of AI architecture, then looks at all these pieces at once. And this creates this amazing side effect that researchers are calling emergent spatial memory. What does that mean? Think about it like this. It means the AI remembers that a chair is still in the room, even after the camera has turned away from it. Object permanence. That's a huge, huge problem for AI video generation, and this is a massive leap forward in solving it. But here's a fun problem. In a world that the AI is literally making up as it goes, how do you control movement? You can't just tell it to move forward. So for that, the engineers did something amazing. They reached way back in time and dusted off this brilliant piece of 19th century math called the Plucker encoder. It's this super elegant way of describing lines and movement in 3-dimensional space. And that's exactly what this encoder does. It acts like a translator. It takes a simple command like move left and translates it into the rigid, unbreakable language of geometry. This basically puts guardrails on the AI's imagination. It's what ensures that when the camera moves, the world changes in a way that makes physical sense. It's the thing that keeps the AI's dream from turning into some kind of chaotic, physically impossible nightmare. So the big question is, how does LingBot World actually stack up against the competition? Well, if you just look at speed, a traditional game engine blows it out of the water, right? 60+ frames per second? Easy. LingBot World is chugging along at around 16. But that's not the whole story, not even close. Look at the other columns. First, availability. It's open source. Anybody can download it and use it. That's huge. And then consistency. It can hold a coherent world together for minutes at a time, which is way longer than a lot of other AI video models. So it's that combination, being free and open and staying consistent, that makes it a total game changer. And that brings us to the master plan.
Because you have to wonder, right? Why would a company pour so much money and talent into this incredible technology only to give it away for free? Well, as it turns out, it's an incredibly smart and frankly brilliant business strategy.
A lot of people in the industry are actually calling this a Linux moment for AI, or maybe the Android for robots. See, by open sourcing the hardest parts, the brain and the world, Ant Group is trying to become the fundamental operating system for the entire next generation of robotics. And this chart right here shows you exactly how that works. Look, they give away the amazing LingBot software for free. That gets a massive community of developers and companies all over the world building on their platform. But, and this is the key, to train and run these mind-bendingly complex world models, you need an absolutely staggering amount of computer power. And where do you go to buy that? Well, you guessed it. You go to their sister company, the highly profitable Alibaba Cloud. So the bottom line is this. Ant Group isn't really trying to sell you a robot. They're playing a much bigger game. They want to sell the entire robotics industry the picks and shovels for the gold rush that's about to happen. They want to own the essential infrastructure that everyone else has to build on top of. Okay, let's zoom out one last time here, because this isn't just about a clever piece of software or a slick business plan. This technology is actually a critical piece in a much, much larger geopolitical and economic game that's playing out on the world stage right now. And this whole software ecosystem, it has a physical body. Meet the Robbyant-R1. This is a humanoid robot, but it's not designed for the factory floor. It's designed for the service economy. Think working in kitchens, helping out in hospitals, or providing care for the elderly. And the critical thing to remember is that before this robot ever takes a single step in our world, it has already lived through millions of possible scenarios inside its LingBot world dream. And you have to understand, this isn't happening in a vacuum. This entire strategy lines up perfectly with China's national mandate to become a world leader in humanoid robotics. That puts Ant Group's work right at the center of a very real, very intense technological race between the United States and China. And that race, it has a deadline, 2027. That's the year. That is the target China's government has set to build up a globally dominant industry and supply chain for humanoid robotics. So this push from Ant Group, it's a massive, deliberate move toward hitting that goal. So all of this, it leaves us with a pretty profound final thought. We're stepping into an era where reality itself can be simulated on demand, creating these infinite practice worlds for AI. And if these AIs are going to learn about our world by living in these generated worlds, it really makes you wonder, doesn't it? Who gets to write the laws of physics for the minds of our future machines?